All right, everybody, welcome back. In our fourth session today, we're going to be doing the lab for association rules. Part of this is going to be sort of word problem type questions, similar to what I showed you in the lecture last time. And part of it is actually going to be going through and applying the association rules algorithm to a data set. Okay. Once again, I'm recording, so I will be sharing a video through a YouTube link again later that you can refer back to in case you miss anything. Okay. One quick thing I want to mention before we get started. A couple of people have had this issue where their shared folder on their virtual machine stops working, right? Where you open up the file and it won't show anything, you can't save things. I mentioned earlier in an earlier lecture, if this happens, there is a way to solve it. In the installation folder, the software folder that I shared on Google Drive, what you'll see, there's a README file specifically that talks about known issues. This is one of those known issues, okay? The file's here through the link on campus to the software installation instructions. So if you go in there, it lists a number of things that I know about that come up a lot. So you should look there first if you're having a problem like this, right? We talk about keyboard layout. Here's the one that talks about what do you do if your shared folder stops working, okay? So give this a shot if you're having this problem first. You go to the terminal, you go to your big data box folder, try running this command, okay? And then try running Vagrant up again. Typically when this happens, the reason it happens is that when your virtual machine was shut down at some point in the past, you didn't shut it down using the X save machine state. So either your laptop lost power and it just closed, or you closed it and didn't save the machine state. Either of those things will break the connection to your shared folder and you're gonna have to reconfigure it essentially, if that happens, okay? So I would give that a shot if you're having that issue. Now, I'm going to bring up my virtual machine again. Recall that if you've shut it down properly in the past, when you come back, you can access it once again using the VirtualBox software, right? So it'll be on your applications folder if you're a Mac user, or you can search for it in your shortcut bar on Windows. And again, it's called VirtualBox. When I bring it up, it looks like this. Here's my VM, right? Big data. I'm going to start it. And I should get my desktop back as it looked before. Okay, you may get a screensaver that's loaded. I mean, sometimes it takes a second to respond. Just press some keys and click the mouse. It should give you your desktop back. Okay. First thing that we need to do, I'm going to go to campus and I'm going to grab the files for this lab, right? And I'm going through a Chrome browser inside the virtual machine. And go to our course. And under additional documentation, I have shared the lab material. Okay, so it's here, Association Rules Lab Session 4. So you're going to need to download the data files, lab2_1.csv, _3.csv. Those are two data files we'll be working with. There's the script, which has the answers already there. I would recommend not just downloading this and using it. I would recommend trying to, I mean, you can do that, have it open to refer to, but it's better if you try to do this on your own, okay? So you actually make sure you understand what each of the commands is doing. And then there's also a PDF file that has solutions to each of the questions. Again, I would encourage you not to just jump and open that, but actually try and see if you can answer things correctly first on your own to make sure you're understanding things. Okay, so grab the data files and the question file. If you open this, it'll just open this in the Chromium browser, right, like that. It creates a new tab, so I can go back to this tab if I want to see those files again. When you download these files, right, they're going to go to your downloads folder. So I'm going to click lab2.1 CSV. And is it actually downloading anything is the question. Open. Let's see what's going on. You can get to your downloads folder just through the browser if you click the three dots. It's like this extended options in the top right of the browser. And click downloads. It'll show you all of your downloads. Okay, so the reason it wasn't doing anything is I already downloaded those files before. So I can see them listed here. I can click Show Folder. It'll bring up my downloads folder like so. And I'll just close this guy. So here I have the 2 data files. They've been downloaded to my downloads folder. I'm just going to highlight them, drag them over here for now to my desktop. This one is an extra download. It's a repeat. I'm just going to delete it. Put it in my trash. Okay, so I've got the 2 data files there. And then I also want to, I'm just going to download the script just for reference. And again, I can go to Show Downloads. Here it is. Show in the folder, and I'm going to copy this to my desktop as well. Okay, I'll close this tab. And again, if you click on the PDF file, it'll by default open it here in the browser window. So, yes?
For me, I just like because I don't have
Mm-hmm.
I just have to open the
Yeah, you can just go, you can download the stuff from campus directly to your computer. If you're not using the virtual machine because you couldn't get it to work and you're working directly on your computer, then yeah, you'll just download it through your browser and save it somewhere accessible. So just because I'm keeping track of my work, I have this business analytics folder that I created last lab, which has a bunch of stuff in it from that prior lab. What I'm going to do in here, I'm opening this, I'm going to right click and create a new folder. I'll call this Lab 2. I'll also make a folder called Lab 1 just to organize myself a bit better. Okay, I'm going to take all the stuff from that prior lab and put it in my Lab 1 folder. Okay. This thing's a bit flaky. Sometimes I drag things and it'll make a copy. Other times it'll move them. So don't ask me why. In this case, I've got extra copies now, so I'm removing these guys. Okay, so I have my Lab 1 folder now with all the stuff from that lab is there. And I have my new Lab 2 folder in which I'm going to drag these files I just downloaded. Okay, just keeping myself organized. This is all purely aesthetic. I'm just helping you keep track of where your stuff is. Okay, so we've got our questions open here, and I've got the 3 files that I need. I'm just going to zoom in on my browser a little bit to see the questions a little bit better. So there are, I think, 4 different questions or 3 different questions. There are 4 questions here. Okay, again, this is a similar format to what your homework assignment will look like. In this case, my suggestion is, and I mentioned this in passing to some people last time because it wasn't as important. I would suggest in general to submit your R script as well as a Word document. Okay, in the R script, you have the commands you use that are commented that explain what you're doing, and in the Word document, you have this a similar sort of textual description that goes with your answer and some screenshots of the output, for example. Okay. If you didn't do that in the first homework, don't worry about it. It's not a big deal. I'll mostly be focused on whether you were doing things properly in the script. That said, going forward, because not all of the problems require R, some of them are written responses, I suggest having a Word document, okay? So I would say take whatever's in the homework questions, just copy it into a new Word document and kind of provide your answer underneath the question, okay? And you can refer to an R script as necessary. So as I mentioned in the lab and similarly in the homework, it's going to be a combination of written questions with written responses, as well as actually, you can use R wherever it helps you, okay, and provide what you did in R as appropriate. So in this case, the first problem is giving you a very small sample data set, okay, of transactions. So each one of these rows is going to be a transaction in your data set, and I'm asking you list the rules, including support percentage, support count, and confidence, that would be generated if you employed these minimum thresholds for support and confidence. You could do this by hand. It will take you a long time. I really don't suggest doing that. You'd get the marks still. I'm not going to penalize you, but you're wasting a lot of time. So instead, what you would want to do is put this into an Excel file or something, save it as a CSV, and then bring it into R and do the analysis there. Okay? Fortunately for you, I've already made a CSV file that contains this data. Okay? That's that first data file we downloaded. So what I'm going to suggest, so our very first thing we're doing here, we're running the association rules algorithm, and we're going to get back some rules with these minimum conditions. So I'm just going to minimize the browser. This is the data set, lab2_1.csv. Okay, I'm going to right click it, and I'm just going to open it with a simple text editor. Mousepad is a text editor. If you're working on your computer, you can open it in Excel or something, but I don't want to get into using OpenOffice here. Okay, so don't worry about it. This is easy for now. Here's what the data looks like. Okay, so it's just that same comma delimited list I was showing you in the PDF file. It's just each basket is a row in the data. This data looks different than the other data you've seen so far, right? It's not columns with ones and zeros. It hasn't been numerically coded. It's actually, this is called transaction formatted data. This is data in this format is actually what the association rules algorithm expects. Okay? It's possible to take columnar data that's been binary coded and convert it into this format so that A-rules can work with it. Okay, but you'll eventually always want your data to end up looking something like this before you call the association rules algorithm. So we have transaction number 1 contain juice, bread, butter, and ice cream, for instance, right? Notice I've got some blank values here. That's not actually a problem. You're going to get warning messages when you import this because R is going to see sort of empty values, like not properly terminated lines and stuff like that. That's just because of the way the file was saved in Excel. It kept some, I had some cells that I put sort of enter. I clicked enter but hadn't put anything into them, so it automatically put commas. It's not a big deal. Okay, but this is what our data looks like. So what I'm going to do now, I'm going to, you know what, I'm actually just going to open the R script because things might be easier. I don't know if we have time to do this all by hand from scratch in 80 minutes. So open up the R script, okay? Okay, we get our studio back. You may have some stuff left over from the last time you were working in our studio. So your environment window, for instance, you may have some variables and things in the top right. What I suggest, just clean your environment. So the way we do that, there's a little broom picture above the global environment window. If I click that, it'll wipe out all the variables in memory, right? I don't have anything to wipe out, so it won't matter. Similarly, if I had a plot, I could wipe it out with the broom above the plot window. Yes?
I get a message that like error opening and no such file or
Okay, if you go to your desktop, can you open the share folder? And is there anything in it? This share.
There's nothing in that.
Okay, that means your shared folder is broken. So this is what I was talking about at the very beginning of the lecture. Okay, if that happens, typically it means that the VM wasn't shut down properly at some point in the past. So if that happens to you, you need to go back to the terminal on your computer or the console if you're in Mac and go back to that folder, the big data box folder, and run that vagrant reload command. So let me just show you quickly. So I'm going to navigate as, so I had a video previously where I showed you how to navigate in the terminal, right? So CD is short for change directory. I'm changing directory to my desktop, to the big data box folder where the virtual machine is. And I'm going to type the vagrant reload command. Okay, notice that it's rebooting my VM. It's redoing the connections to the hard drive, right? It's remounting shared folders and stuff.
But what about if you still have something in the shared folder?
Then you're fine.
When I open it, I still don't have it.
So what's in your shared folder? What appears there? Okay. 1 second. So recall that we log in, username vagrant, password vagrant. Okay. In an ideal world, doing that when you come back up, if you couldn't see something in the shared folder, you can now after you do that. Okay. Assuming you were able to get your script to open, you should be able to see this now. Okay. And again, a couple things you can try, like I said, try reloading the shared folder if it's not working. If it is working, try opening it by navigating through your folder structure using this open file command. If that's not working, Try closing RStudio and reopening it. Okay, that's what worked in the last person's issue that I was just dealing with, Tiffany's issue there. So assuming you got this to work, you will see the script here. You will need these two packages. The A-rules package is obviously short for association rules. There is a second package called A-rules viz, which is for creating visualizations that go with association rules to inspect the rules more easily, right, in a visual fashion. If you haven't installed these previously, when you run these two commands, so remember to run a command from the script window, put your cursor on the line that you want to run, and press Control and Enter at the same time. Okay, it copies that line to your console and executes it. If it's installed already, you'll just see some sort of success message like this. If you haven't installed it previously, it'll say it doesn't know what that package is. That means you need to install it. Few ways you can install a package. This is good reference information just in general for using R, because you may need a new package at some point in the future. In the bottom right, where our plot window is, or in our help files, where those would show up, there's another tab called Packages. Okay, if I click that tab, it gives me a list of all the packages that have been installed on my version of R. If something is checked off, that means it's been loaded into memory. That's what the library command does. If it's not checked off, it's not currently loaded into memory. You need to load the package into memory to be able to use the functions that it provides. Okay? So I just loaded the A-rules package with that library command. You'll see A-rules is here and it's checked off. If A-rules is not there, it means you have not yet installed it. So if you want to install a new package, there's a nice install button here. Okay? You can type in the name of the package you'd like to install. In this case, I would want to install A-rules. Okay? This first option, install from, there are many different servers around the world that people are hosting that you would need to set up if you want to use them. Something closer to where you live will download faster, for example. The default one is the CRAN repository. It's like the main one that everybody uses. Okay? I put the name of the package here, A-rules. Again, you don't need to do this if you've already got it installed. You're fine. For instance, if you have the virtual machine working. And then there's an option about where it can install it to. Just leave it default. And you can check off this checkbox if you want it to automatically install associated packages that this thing needs to work. Okay? So you would just click install and it'll go through the installation process. As I mentioned, I don't recommend waiting until the labs to do this because some of the packages are pretty big and the Wi-Fi here is pretty slow, so you're going to be sitting here a while waiting. Okay? Do it ahead of time. So I've loaded A-rules. I'm going to run the next command, which is just to load the A-rules viz package. Okay, and those are both now in memory. Now, to answer this first question from the lab, we're going to need to load that data set that we just, well, the first data set among the two that we downloaded. And recall there were two files. One of them is lab2_3. The other one is lab2_1. I'm guessing you can guess which one is for the first question. It's _1. So we need to load this file, the one we just opened and inspected in a TextPad. What we were working with in the past with the last lab was this read.csv file. That's a native function that reads CSV files, and it assumes columns of data, like I talked about, right, where every column is a variable. We know our data doesn't look like that. So we can't use read CSV with this data, or we're not going to get the input we expect. Just to quickly show you what happens, I'm going to call read CSV. And I should probably save the output into something. So let's say mistake. I'm going to open this file. You don't have to follow along with me, by the way. I'm just going to show you what happens if you don't do this properly. Okay, so it read my data into a new variable called mistake. 7 observations of 5 variables. But when I view it to see what it looks like, it assumed the first row was the variable names, which was not the case. And then it tried to populate the values using the next set of rows. And then it realized, oh, we've got a value in the 5th column, and we don't know what that's called because there was no such thing in the first row. It gets totally messed up and confused, okay? Because the data is not in the format you think it is. You can't use read.csv with data formatted this way. So I'm not going to use that, obviously. What I am going to use, there's a different read function called read.transactions, which is specific to reading transaction formatted data, this comma delimited list of items that showed up in a transaction. Okay? This is not a native function in R. It comes with the A-rules package. Okay? So So you can't use the import data set. This stuff will not help you with association rules data, with transaction formatted data. You have to import it this way with the command. Now, that said, you can either pass it a file path if you know the file path for your file, or you can just use that same file.choose function that we used before. So I'm going to delete this for now, because your data will not be in that folder. That's a folder on my computer. Okay? So I'm going to put file.choose. So it's going to, when it wants to figure out the path, instead of passing it a text variable that says this is where the file is on my computer, I'm going to tell it use the file.choose argument, which is going to open a browser window in your file system. So I'm not running it yet. So that's the first argument. It wants to know where is the file. Well, we're going to look for it manually. Okay. Comma, second argument. What's the format of this data? The data that I showed you, that's actually known as basket format. So I need to tell it that. So format is the name of the parameter that this function needs to know about. And I'm giving it a value. So the format parameter is going to have the following value. Recall that C is short for, it's not exactly this, but a comma delimited list of items. In this case, it only needs one value. Okay, and the value is going to be basket in brackets. If you want to know what other formats it can handle, look at the help file. Okay, as I showed you how to do in the past. Bless you. So we know the format of the data is basket format. I need to tell it how are the values separated. Okay, if I don't put this here, it'll guess. Usually it'll guess with a comma. In this case, it's correct. And then I'm telling it rm.duplicates. You don't actually need this option here in this case because there are no duplicate rows. But if you had, this is actually duplicates in terms of values in the list. So if you see the same item twice, it ignores the second and the third and the fourth. It just knows, yes, this item was here. So it's binary yes, no. It's not counts. Yes?
Why are we leaving an empty string instead? Like, for example, we're using like a library, I guess. And then in the list, the second object, sep, we're leaving as an empty string.
It's not an empty string. There's a comma.
How we're going to divide
This is,
the data.
yes, SEP means separator. How are the values separated? Okay. If you leave these blank, there are default values. It will guess. Usually it'll guess that the values are separated by commas. Sometimes it'll be wrong. So you need to look at the data before you do that. Okay. Okay. So
could you like for the ARM duplicates, so if it put like true, that means that like it's not gonna put in any like second or third value that's repetitive.
correct.
If I put in false, it would put the
It'll keep track of sort of counts of those items.
false.
So I'm going to just tell it, just for sake of simplicity for this lab, I'm going to tell it to ignore duplicate values. Right? It's just looking for yes or no, the item was there or it wasn't. Okay? So all I've changed on the line from that script file, I've deleted the file path. Remember the first argument is where's the file, and I've replaced it with file.choose, parentheses. Call that function. Okay? So I'm going to run this command. It's going to initiate the read.transactions function from the arules package. It's going to pass it these arguments as input, right? The first input says look for the file manually with a window. I'm going to do that next. And whatever the output is of this process, save it in lab2_1. This will be a new data frame in memory. Actually, it's not a data frame. In this case, it's a transactions object. But you'll see what it looks like in a sec. Okay, so I'm going to run this. Again, Control-Enter with the cursor on the correct line in the script window. Is everything okay back there? Yeah. Okay. And I get my file browser. So I'm going to navigate to that CSV file. If that didn't work and you didn't get that window popping up, it means there's some syntax error in what you've written. Lab2, lab2_1.csv. Open. Okay. Everybody okay? Everybody with me so far? Is it an error or a warning?
Error.
Okay, what's the error say?
Unexpected symbol. Yeah.
That's a syntax error. So that means something is not typed correctly up here. File.choose open close parentheses, comma format equals C in parentheses, bracket, or basket rather. If you got this warning, that's fine. I mentioned earlier there's some commas with no values in them when we looked at that text file. That's what this is talking about. It's just warning me that there may be an issue in my data file. Yes, spaces often matter. Yes. If it worked, you're going to get in your data list in memory under the global environment lab2_1, formal class of transactions. This is the data type. Okay. So this is not the same as a data frame. If you try and view this, you'll get an error message. It doesn't know how to view this kind of object because it's association rules type data. Okay. If I click on it, it's a bunch of metadata describing what the data looks like, but you don't actually see the values. Okay, all of that is expected. All right. So we have the data read in now, so hopefully. I'm going to show you a few basic functions you can use to describe that data. So, first one, item frequency, all one word with a capital F, right, is a function that comes with the association rules package. It's used to describe how common each item is in the data. So I'm going to Control Enter to run this command on my lab2_1 transactions data. And you see what it spits out on the console is proportionally, this is support percentage for each unique item, right? How frequent is it across the transaction data? So bread appears 62.5% of the time. Butter appears 25% of the time. Cereal half the time, right? That's what this means. Okay. Any questions about this? No. Okay. The next command is visualizing that for you. So it's just going to make a little bar plot. So item frequency plot, right, is the name of the plotting function here. Pass it the data you want it to plot, and then tell it what type of plot. The alternative to absolute is probably relative, if I had to guess, but I'm not sure. We could look at the help file. Essentially what this means is that the height of the bars should be the count of transactions it appears in, as opposed to the fraction. Okay? So it's dictating what's the y-axis. Okay, here's my plot in the bottom right.
So for this one, you just type like command enter and
Yeah, so for all of these commands, the way I run them is Control Enter, and it'll copy it, or Command on a Mac will work too. That's the next command you've run. You ran image, which is the next one we're going to get to. So this command is called item frequency plot. Yeah. Okay, so it's essentially a histogram. How common is each item in the data set? So we see here juice is the most common. It's in 6 transactions. Okay, if I want to add a title to my plot, by the way, this is how I would do it. I can call this title command and just tell it main title is, and then give it a value, and it's going to stick it there. We're going to get back to visualizations at the end of the class, so don't worry too much, but just showing you can configure the plot and design it a little bit. Okay, see it adds the title. So that's one simple function we can use to inspect our data to see how common each item is. This image function, it has a special representation for, again, association rules type data, transaction data. So when I call this, it makes this grid. And essentially, what's on the x-axis here is an item code. So if you want to know what is item 1 or item 2 or item 3, right, I can show you in a second. On the y-axis, it's IDs for different transactions in the data. As you can imagine, this is not a very useful visualization with a big data set, okay? Because you're going to get hundreds of labels in each direction, and it won't help you very much. It's fine for a small data set, okay?
But how do you choose like the, for example, if you want to mystery graph or like if you want to draw the graph?
If you want to know what visualizations you should be using, we'll get back to that at the end of the class. Like at the very last set of lectures is about visualization. Yeah. Okay, this next command, item info, tells me what did those labels refer to. So item number 1 is bread. Item number 2 is butter, okay, if you wanted it. That's how you can use this in tandem with the image function to understand what's appearing where.
Could we have this item labels on the web?
You could, yeah. I'm not getting into it here. Again, we'll get back to manipulating visualizations later, but it is possible to do that. And it would be a good idea. Okay, so assuming we've looked at our data, we've visualized it a little bit to understand what's going on in the data. Next step is we're actually going to try calling the association rules function, right? It's called, in this case, the a priori algorithm, right? If you don't remember that, that's mentioned in my slides from last class. You can look back to what that means. Essentially, this refers to using a minimum support and a minimum confidence to filter rules, right? To speed up and pare down the data set. So we call the a priori function here. In parentheses, we pass it arguments. It needs a few things. The first argument is what data should it use? Okay, and we have this lab2_1 transactions data we read in earlier, so that's what it's going to run on. Comma, next option. Actually, the next option is a list of parameters. It's called parameter, and we're giving it the following values. It's a list of, SUPP is short for support, so this is the minimum support value. Okay, any rule that is returned, it has to show up at least 3/8 of the time. Minimum confidence, only show me a rule if the confidence is at least 65%. Okay, why am I using those values? Well, if we look at the questions, which I appear to have not retained. So let me bring them up quickly. Those are the values I asked you to use, all right, in the lab question. Right here. Okay, so the question says, given these 8 shopping baskets, list the rules with support percentage, support count, and confidence that would be generated from this data set, assuming a support threshold of 3 transactions, that's support count, 3 of the 8, right? Note that these parameters, when you call a priori, they expect percentage measures, okay, which you can specify as a fraction or you can put in a decimal. So I put 3/8, right, to give it the percentage value. That's equivalent to a count of 3. And then the confidence of 0.65. Okay, so I'm going to run this command and store the output. So the rules that it gives back are going to get stored in this new variable called rules. See, it's done. It takes, I don't know, a fraction of a second. It's a pretty small data set. I can tell you, even with a much larger data set of hundreds of thousands of observations, it'll be about that fast. Okay, the computational burden is not very high with this algorithm, at least when you don't have that many columns, that many items. So I have this rules variable that appeared in my environment window. Again, it's not like a data frame, right? You can't just look at it. Actually, what you need to do is use this function called inspect, okay, which also comes with the arules package. Before I inspect the output, I'm actually on line 34, taking the result that I just got, and I'm sorting the rules that it gave back. I can sort based on lift, I could sort it based on confidence, I could sort it based on support, right? Here I'm just sorting it by lift, which actually is what it does by default, I think, anyway. But that's how I would reorder the rules in the output. So I'm storing it, that sorted version of the output, in a new variable called rules_result. And now I'm going to inspect that sorted list. Okay. I get back 5 rules that meet those minimum conditions. Okay, so essentially the algorithm, as we talked about last class, is going to come up with every permutation and combination of items that it can think of, right, that are possible given this data, and then it's going to evaluate the 3 metrics we care about automatically for each one of those rules, throw them away if they don't meet the minimum support and minimum confidence values that I told it to use, and return back what's left. Okay, and I can sort them and figure this out. So what's left here, again, it's sorted on lift. The rule that came back with the highest lift that's of all the rules possible was this rule: ice cream leads to bread. Okay, if ice cream, then bread. These 2 items show up together 37.5% of the time. The confidence is 75%, and the lift is 1.2. Okay, or you're 20% more likely to buy bread if you have ice cream than people in general. Okay. So what did I ask you for? So I asked you identify the rule with the highest lift. It was the first one, right, that I just mentioned. List the 5 rules you got back. And that would be your answer. So you would, you could provide your R code, the output, and then you can interpret the result. All right. Any questions about that? No. Okay. Yes.
How would we put that photo if blank then juice?
So if you get a rule that looks like this, right? So the question's about this rule. Essentially, this means there is no precondition. So this is the same thing as saying a rule with just juice in it. So this is just going to give me back the item support for juice. The confidence is conditional on nothing. So again, it's just, again, the support, right? And then the lift is, you know, if I do anything, again, it's not a very meaningful rule. You could ignore this, essentially. It wouldn't be useful.
Sorry, for lift 1 signifies chance anyway, right?
Yeah, and that's not surprising, right? Because essentially all that appears is juice in the numerator and juice in the denominator, the support values.
But
Right.
even for cereal and juice, it's the same. It's more like, it doesn't tell us that much. It's for the
Cereal leads to juice.
like the last
Yeah,
one.
this is saying the entire co-occurrence can be explained by chance.
Oh.
Yeah. Right, as opposed to 1.2 is saying this is not explained by chance.
Mhm.
Okay. Any other questions? No? Okay. Okay. Problem 1, there's a part B to that question, and it says, what would this data look like if it was coded in dummy format? Anybody want to explain what it would look like? Sure. Yeah.
Like a matrix with columns for the different products, and then we have 0, 1 for either like the existence of the product that it was bought or not.
Right. Yeah. So very quickly, so I just made these values up. That's not the exact values you would get, but yeah, every column would be the name of an item, and then it would be a 1 or a 0 depending on whether it was present in the transaction or not. Okay, so you could actually give me the dummy coding in a matrix, write it down, show me what it would look like. That's what I would expect to see for a question like this.
Can you show
Yes.
us how to do it?
You don't do this in R. I mean, you can do this in R.
Yeah, that's what I'll.
Okay,
Yeah.
like use on that.
So I think, do I have this in the script? I guess I do. Yeah, okay, so I show you how to do it in R if you'd like to do it in R. So essentially I'm taking the data set that I read in as transactions. This function as is a function that you use to cast variable from one data type to a new data type. So it's saying essentially convert it from that format to this format. And I'm saying convert whatever format it is, right now it's transaction data, into matrix data. Okay, and then store the output in this new variable, lab2_1_ as matrix. So I run that command, and we see here, we have this variable showed up in the top right, lab2_1_ it's as matrix. This is not a data frame, but you can still view it like a data frame. They're very similar. The difference is a matrix is always numerical or logical. It can't be characters. It doesn't handle strings. If I view that data just by clicking on it, right, I just clicked on this variable, it displays in the view window. I see it's a bunch of true and false values. If I want to work with this data, if I want it to be binary, then I actually need to convert those true-false values, those logical values, into numbers, 1s and 0s. So that's what this next command is doing. I'm calling the replace command, and it's saying find and replace, essentially. So in this new variable, this matrix, look for values true and false, and replace them, respectively, with 1 and 0. Store the output on top of that same variable. Use the same name. Okay. And now I've got ones and zeros. Okay. So yeah, that's how I get to the dummy coding representation in R if I wanted to do that.
Is there anything wrong if it shows that the reverse transitions for all the items?
That's because at some point I read the data. Wait 1 second. Yeah, because it's dealing with the first row and assuming it's headers. It's not dealing with it as headers. So actually, what you get back here is not correct. 1 second. So this is correct. Lab 2.1 as matrix, replace true and false with ones and zeros. Something weird's happening with the first row. Let's try instead. We can try this. No. Okay, so yeah, good catch. When I'm replacing the true and false with ones and zeros, the first value is not being overwritten properly. I'll fix this after class and just post an updated script rather than stopping, since we're getting low on time. I'm just going to comment that out for now. Okay, so watch for that. This command is not doing the conversion between true, false to ones and zeros properly. Something's going wrong in the first row. Okay. Problem 2, you don't need R for this one. So problem 2 is kind of like a math word problem. I'll come back to that. I want to get through the scripts first before we go to do the paper and pencil stuff, just to make sure we get that stuff done. So let's skip to question 3. Here we have data, which is actually columnar data this time, and we have nominal values. So we don't have numeric, we have low, medium, and high, for example, in income, male and female for gender, education, right, and credit risk. These are all nominal values that need to be dummy coded or converted to transaction data before we can work with them. So again, I've given you a data set on campus. This is the other data set, lab2_2.csv. It's populated with this data. And I'm asking you again, what are the rules, again, including support and confidence values that would be generated from this data. I'm giving you a minimum support and confidence threshold. And then I'm asking you to again tell me which one has the highest lift, what is that lift value, and then I'm asking you to interpret the lift value and tell me what it means. So essentially it's similar to the first question, except our data is formatted differently this time. So the first thing I need to do is read that data set into R. In this case, because the data is essentially like a spreadsheet where I have columns with values, I can use read.csv to read it. It'll read it properly. Then once it's read in as a data frame, I convert it into transactions data before I work with it. Right? So I essentially take it from the columnar format and convert it into comma delimited lists. So I'm using read.csv here, the same one we used last time in the last lab. I need to tell it where the file is. Again, if you know the file path, you can write it here as a string with double quotes around it, or you can use file.choose and navigate to find it yourself. Okay? So I'm just going to delete this string and replace it with file.choose, parentheses. And I'm going to run this command. Find my data. Okay. And now it's been read in. Here it is, lab2_3, 12 observations, 4 variables. I'm going to click on it. Here's my data. Okay. It should look the same as the data that was in the PDF file, assuming I didn't make any typos anywhere. Okay? Assuming that you succeeded in reading that data in as a data frame, the next step is to convert it into transaction data so that A-rules can handle it. So that's what I'm doing again. I'm using the as function and I'm saying convert whatever data is stored in lab2_3 into transactions data. Okay. Now we have lab2_3 was overwritten, and it was overwritten with formal class transactions data. So again, I can't view it anymore. Okay, but now it's a common delimited list that A-rules knows how to handle. No, because read.transactions is for reading a file from your hard drive natively. Here I'm reading the data frame, so it's based on what's the format of the data in which it's stored on your hard drive. If it's stored in columnar format, you'll want to read it in as a regular data frame first, using, say, read.csv. If it's already stored on your hard drive as a common delimited list of items in the basket, then you'll read.transactions. Okay? So I've read this data in. I'm now converted it into transaction formatted data, and now I can again call the a priori function on that data set. So I'm passing it this transactions data is the first argument, and the second argument again is a list of configuring parameters. So I'm saying a list where the support value, this is minimum support, is 3 out of 12. That's from the question. I told you what minimum support to use. I'm also giving you the confidence value of 70% there. EXT just means report extra information. That's an optional argument. It's like verbose, like it gives you lots of details about what it's doing. It's optional though, you don't need to have that there. If you do this though, I think actually what ends up happening is it gives you back additional information about support and confidence metrics. You need to have this here specifically for it to report to get, I think it won't give you back support count by default. It will only give you back support percent. But anyway, it's an optional parameter for additional info about the rules. So I'm going to run this command. Okay. I can again sort the values by lift if I wanted to, or something else. It makes sense in this case to use lift because the question asked you which rule has the highest lift. I'm storing the output of the sorted version in this variable called res, and then I'm going to inspect the results. Okay, if your window, your console is not big enough, it wraps and starts printing below, so it's harder to read. Obviously, my window wasn't big enough, so this is why we got this. I can expand the window and rerun the command. Okay, and now I can see the whole thing. And it's giving us alternative rules here. So we have, if credit risk equals high, then income level equals low income. That's a rule with the highest lift of 3, and it's actually tied with the next rule, which is if my income level is low, then my credit risk is high. So remember that lift, if you flip the rule around, the lift value doesn't change because it's all support values that it's based on. So this is exactly just the same rule inverted. It doesn't distinguish. Notice the confidence is higher with the first one though. So you might have a slight preference for the first one over the second one, right? Something about possible ordering what's causing what. They both have support of 25% in the data. Okay, so either one of these rules would be fine. You could report both and say that they're tied. That would probably be the best thing to do. And then interpret what the lift value of 3 means, right? People who are high risk are 300% more likely to be low income than people in general, or conversely, people who are low income are 300% more likely to be high risk in credit.
Would it be 300 or 200%? Sorry, I'm a bit confused with that. Because it's one.
Oh, you're right. It's a 200% increase.
Yeah.
They're 3 times as likely.
3 times or 200%.
Yeah. Yeah. If you're 100% more likely, it's lift value of 2. Yeah. Good point. Okay. So, the last thing I have here, as I mentioned in the lecture, this is the only value, lift, where you can actually get statistical significance for it as well, right? You don't need to know too much about specifically why that's the case. Basically, it's that the denominator in the lift is based on probability theory, the probability that 2 things happen together when they're independent. That's your null hypothesis. The numerator is what's observed in your data, and you can actually come up with a statistical test for is the observed thing far enough away from the null to say it's significant. So the way I call that is dot significant. right? I tell it what rule output to use that I'm testing this with, what was the original data that was provided so that it can figure out the denominator, right? And then what's my threshold of significance? So the thing that I'm seeing has to be, this would have to occur under the null hypothesis being true no more than 1 in 20 times, right? So you'd have to have a 5% chance of seeing this result under the true null, like for me to care about this. It has to be that far in the tail. If I run this command, what it gives me back, it's a vector of true and false values. So these are for the rules, right, that are stored here. So if I look up, the false means the first value, credit risk high leads to low income. That's not statistically significant at a 0.05 threshold. Similarly, the second one is not statistically significant at a 0.05 threshold. None of these are. Partially that's driven by the fact that we have a super tiny data set. Okay? So there's no statistical power. That said, if I rerun this command and I change my threshold such that this only has to be so extreme that I would see it 10% of the time if the null hypothesis was true, that these things were not associated. Now I start to see some things that it deems statistically significant. Right? The third and the fourth rule come back as statistically significant at that threshold. Being graduate leads to being low risk, or low income leads to being an undergraduate, right? Those are statistically significant lift values in this data. 1, 2, 3, and 4, yeah. Low risk leads to graduate, and graduate leads to low risk, I see. So it's these two together, the same lift value. Okay. If you're not familiar or you don't recall from stats class what a p-value is and all this other stuff, it's not a big deal for this course. I'm just showing you that it's there and you can use that if you'd like, as another way of evaluating rules. Okay, any questions about that?